Hi, this is number 24 lecture for Friday, and it's got two chapters, 10.1 and 10.2. And we start with this idea, solving quadratic equations instead of factoring, which is what we've been doing. We're going to use something called the square root property. And that just says that if you have something squared equal to a number, then if you take the square root of both sides, you get two solutions. So you notice if you take the square root of x squared, you just get x. And on the right-hand side, we want to consider both the positive and negative square roots of the numbers. So we'll see some examples now. And the first thing to do is get the square by itself, to get the square isolated. So if I add 25 to both sides of this, it's going to say x squared equals 25. Before I even write anything, think, what could we square and get the result positive 25? 5 squared is 25. Negative 5 squared is also positive 25. So the thing to do now, and I'm doing more writing than I really have to, but as I always say, I'm explaining it, so I'm trying to do it in agonizing detail. On the numerical side, I put a little plus minus sign to indicate that there are going to be two numbers whose square is 25. Square root of x squared, of course, is just x. And then we have plus or minus. The square root of 25 is very cooperative. That's exactly 5. As I said a moment ago, both these numbers will work here. Square them and you get 25. So, of course, back in the original, square them, you get 25, and then you take away 25 and you get 0. So that's the use of the square root property. This one says some number squared gives you 3. Okay. We'll try it. Take the square root of the left side, and on the numerical side, plus or minus square root 3, and that's now just plain x. And since the square root of 3 is irrational, it's a decimal that goes on, it's 1.73, yada yada, goes on forever, we just leave the answer like this. If somebody wants to put that in a calculator and change it to a decimal, that's fine, but then they're going to have to round off, and we don't want to round off. Let me just show you that. I'm not making this up. Square root 3 looks like that, right? So if I write 1.73, if I say equals 1.73, I'm not exactly telling the truth because that's rounded off. If I put a little dot on top of the equal sign, that indicates approximately equal. Okay? Should you change this and round off? Only if you're explicitly told to, or if you're making a part, or you're 10 years down the road and you're on your engineering job, or you're a doctor or something like that, and you need a real number to work with. But we leave it like this. Okay, I want to get the x squared by itself. Problem 3, get the x squared by itself. So I start by adding 48. And then I divide by 3. And if you can finish this in your head, that's fine. I'm going to write out the steps. Now I'm going to take the square root of that side. And on the number side, I write a little plus minus. And I get x equals plus or minus 4. So 4 or negative 4 squared would give you 16. Times 3 would be 48. Take away 48, 0. So, now here's a step up. It doesn't say x squared. It says these parentheses squared equals 16. The same principle can be used, though. The same steps can be used. We have something squared equal a number. So let me rewrite this here. This is a long bunch of work today, so you might want to stop the videos at some point and go make coffee. 9 pages altogether today. So on this side, the square root of the square of the parentheses leaves us with just the parentheses. On the right side, we got plus or minus 4. And we're not done until we have x all by itself. So I could take away 2 from both sides. I could say plus or minus 4, take away 2. But what we like to do here, and you'll understand why after you've done enough of these that this is the better way. I'm going to say add negative 2 to both sides, which would leave just x over here. And when you add the negative 2 on this side, just squish it in here right after the equal sign. So it says negative 2 plus or minus 4. Now this represents two numbers. Negative 2 plus 4. Negative 2 plus 4 would be a 2. Negative 2 minus 4 would be a negative 6. So if you leave it like this, it's fine, but just understand that it means this. And for Alex, I think Alex will ask you to write distinct solutions separated by a comma. But if you go back here, put in a 2. 2 plus 2 is 4. 4 squared is 16. Put in a negative 6, the less obvious solution. Negative 6 plus 2 would be negative 4. Negative 4 squared. See, that also works. Number 5, way over here. And I said impossible because if we attempt taking the square root on this side, there is no square root for negative anything. There's no real number square root of negative 36. There's no number that squared gives you a negative 36. So this one we say no solution. If you get x squared equals some negative number, you can say there's no real solution. And there are what are known as imaginary or complex solutions, and we used to cover those in this class, but now we kick them up to the next class, so you don't have to worry about those. Okay, so this 6a is not that different from 4. It's just got a little more window dressing. So I'll start by taking the square root of both sides, because I have this parentheses squared equals a number. And I'm learning now to make a little more room here for the plus minus. Now, the square root of the square of the parentheses leaves us just the parentheses, and on the other side we got plus or minus. Nice convenient perfect square number there. 49 squared of that is 7. And now I'm going to add 4 to both sides. I'm going to jam it right in there. I'm going to have 3p equals 4 plus or minus 7. Finally, to get the 3 to go away, I got to divide both sides by 3. So that would look like this. And then our final answer looks like this. P equals 4 plus or minus 7 over 3. And I'm not going to do this for everyone. It gets pretty boring. You might be bored already. Who knows? But I'm going to separate these into 2 solutions just so you can see how that works one more time. 4 plus 7 is 11. So 11 thirds is one solution. 4 minus 7 is negative 3. And negative 3 divided by positive 3 would be negative 1. So there's your solution written in that style, and there it is separated into 2 distinct values. Okay, on to number 6b. This is not a perfect square, but we're not going to fuss it. We're not going to fret over that. That's a good word for it. We're not going to fret. Take the square root of both sides, because we already had something squared equals a number. On this side, plus or minus root 7. And this just erases the parentheses. And just like the one before it, I'm going to add 4 to both sides. and then divide by 3. Whoops, I wrote it wrong. Just like in real class, huh? Dane making mistakes. Okay, 3 goes down there. So if we separated this out, it would be 4 plus root 7 over 3 and 4 minus root 7 over 3. And if we needed a decimal, we'd punch this in the calculator. You know, do 4 plus the square root of 7 and get the decimal number and then divide it by 3. Or 4 minus the square root of 7. Get that number and then divide by 3. Okay? This one doesn't have the square isolated yet, so we would start by subtracting 15 from both sides. And we have 3p minus 4 squared equals 21 take away 15 is 6. And now I take the square root of both sides. Lots of writing again, huh? Oh boy. Okay, on this side, we now have eliminated the parentheses. And on this side, we have another irrational number. Square root of 6 doesn't simplify or anything. So we're going to add 4 and then divide by 3. So we'll have p equals 4 plus or minus root 6 divided by 3. Okay. One more here and we'll be done with page 1. I'm going to take away 23 from both sides. I'm going to write this out just so make sure you see where I'm coming from. We've got 3p minus 4 squared equals negative 13. We see something squared equals a negative number, and the alarm in your brain is going, can't do that. So you can't square something and get negative 13. We can stop right here and say, no solution. Because you can't take the square root of negative 13. That's the end of page 1.